Now we will discuss about the mutable sequence. So mutable sequence, that means you can change the sequence data. So you can add a new element, you can remove the element from it, you can replace the element at particular index, right? But when we do change the mutable sequence data, then this does not mean that this entire memory address will change. So when we do change the sequence data, the memory address of the sequence does not change, but the internal state of the sequence changes. To understand that, consider these examples. So consider these examples. So first we are replacing the element. Here we have this list. Then before changing the value, we are trying to check the ID of that list, and then we check the ID of list after changing the internal state of the value. Let's try to run this. Here we can see that the address has not changed, but this list has changed, right? We can also remove all the element from the sequence using a clear method. We can do so. Here we have removed, but this is not the same as assigning a empty list. Like over here we have this list, and now to remove the element, here we are assigning a new list to this L object or to L variables, and then we are trying to check. So in both examples, the element has been removed, all the element has been removed. Here we have used the clear method, but here we have used the assignment method. We are assigning here we are assigning a empty tuple. So in this type, when we do this step, the memory address of the list will change. But when you do this steps, the memory address will not change. Consider these example for that. Here we are trying to check the ID of list before applying the clear method, right? And after applying the clear method, which is the same, right? Comparatively here also we check the ID of the list after assigning a empty list, right? We are also checking the ID of that. So here we are checking the ID of both list, right? So we can see that this address is different than this. So this means that if you do replace, so this is like a replacing the list with the empty list, right? So this address will change, right? Now, why is this matter? Why we are talking about that? For that, consider these example. To understand that, consider these example. We have this suits, and then we have this list element. We have the spades, hearts, diamonds, and clubs. And then what we're trying to do in this second line is we are just assigning a suits object to alias. So whatever the suits is, the alias will also be there, right? So whatever so again here what we're trying to do is we are trying to say that alias is equal to suits. That's simple. So if you try to print the alias element, right, like this, here we are printing the suits and the alias element, both have the same element. But consider these example. When we say suits equal to this empty list, so question is, does alias will still have this element, or it will also be replaced with the empty list? Let's run the example, and here we see that. So this is like first we set that alias will be suits, and then we are changing the value of suits. So alias have not changed, but the suits value have changed, right? Now consider these example, right? Here we have used the item assignment, and here we are using the method. We are using the clear method. Suits have the same four element: spades, hearts, diamond, and clubs. Now alias is equal to suits, but now we are saying that suits dot clear. This means we are using a clear method, right, to remove all the element from the suits. But now so whatever the suits is, that will be alias. Now we know that we are not changing the another value of suits over here. And now let's try to print the value of both suits and alias, and here we are getting the empty. So this is what our desired output was, right? So that's the reason we should always use the internal method, right? We can also replace the element using slicing and extending slice, right? So here we have this list. We check the ID of list before changing anything to this, and then we are slicing the list and changing the value. So this is like, so when we do so, this is like we are changing the part of the list. We are not changing the entire list, and then we try to check the ID after that. So here you see that ID have not changed, right? We can also use appending and extending. So like over here, here we are using the append method to change the value, to add a value to the list, and then we are trying to check that whether the ID will change or not. It will not, ID will not change. But when we use a concatenation to add an element, this is also another technique, right? We have this list, we check the ID, and then we are adding a list of 4. So this is like concatenations, right? And then we try to check that whether the ID will change or not. Of course it will, because when you concatenate two objects, it will create a new object, right? And then here we can see that the ID has been changed, right? If you want to add more than one element, you can use, instead of append, you can use the extend method. In this scenario as well, the ID will not change, right? Here, because in the extend method, the value we are using as a set, which is not a good if you are if you are expecting the element in a good order. But instead of this, you can use tuple as well, right? It will give you the expected ordered output, right? Now let's try to use the remove element. Here, to remove the element, you can use the pop method. Here again, the pop method will also return you the element. It will also return you whatever the element has been popped, right? So here we're saying that l dot pop 1. This means that we want to remove the 2. So 1 is at the 0th index and 2 is at the first index, right? And then we try to hold that element to the popped this variables, right? And then the value will not change, right? If you do not pass any index, so by default it will pop the -1 position value, which is it will pop the last position 4 element, right? Now let's try to use the insert method. Again, to insert, you can use the insert method. Here you need to pass the index and then you need to pass the value, right? Again, so what we are trying to see as a pattern as, whenever we are using a method, right? So ID is not changing. But whenever we are using another shortcuts like concatenations, right, assignments, right, these type of method, so the memory address changes. So we have to keep track of that whether we are changing the object or not. And most of the time we do not want to change the memory, or we do not want to change the address of the object, whatever the internal state we are changing, right? You can do the reverse using reverse method, right? Here we are using the reverse method to do the reversing and the ID will not change. But we have the another method. The slicing technique will also reverse the order. We are using colon colon -1. This will reverse the order. But here we have this, so the original list was 1 2 3 4, but now we have 4 3 2 1. But what if I do this technique to reverse it? Now because we are using another technique, we are not using any method of the list. So this is uh, slicing method, right? So this means that we are entirely, after reversing, we are entirely assigning to the L object. So we are creating a new object over here. In this sense, we'll have a difference in ID. We can see that, right? We can also use, so how do we copy it? So to copy, we can use L dot copy. This will copy the element, right? In the copy here, because we have done the copy. So again, what we have seen this in the earlier lecture, in the earlier video, that copy creates a new object, and that was expected. Here this is the another object and this is the another object memory address we are seeing, right? So using copy is not like the same object. So if you do the copy using slicing, probably they are using the copy method. This is very much similar to the copy method, because in the slicing object also the memory address changes, right? And yeah, that's it about the mutable sequence type. Thank you very much.